one, that blue one, that blue one, that blue one. I'll stop. All right, there's a couple of them, right? And let's imagine this one makes you have red hair. This one makes you have legs where your arms should be. This one makes you have two mouths. And this one, I don't know, makes you backwards. Doesn't really matter, right? Doesn't really matter. But then you guys have an infinite number of kids, right? What do you think is going to happen? Do you think more of the kids with the disease are going to have two mouths, or they're going to have red hair? They're going to have two mouths. It's very unlikely for a crossover to happen here versus a crossover happening here. There's just more genetic space. So if you had an infinite number of kids, and we didn't know where this disease-causing agent is, we could find everybody who has the disease and correlate how often they have two mouths or legs where their arms are supposed to be, or red hair, or, what was this one? Backwards. Yeah. I don't know how you can be backwards. It works, right? So you can calculate then what the probability of those co-linkages are. And from that, you could say that if you then mapped out how often it happened with being, having legs where your arms are supposed to be is only this amount, and you have this amount. Now, if it turns out that this and this amount are exactly the same height, right? And you don't know if it's up or down, but you can also cross-correlate how often these two went together, and these two went together, and these two went together, and you can cross-correlate all of those statistics. And so from that, you can basically, it's not truly triangulating, but you can think of that way. You can narrow in and mathematically eliminate the possibility. Because if you only use one marker, say this marker, you don't know if the defective gene is exactly this many centimorgans south or north, right? But as soon as you use additional genes, and you know the location of these defined markers, and we have many, many such markers for each and every chromosome. This is one individual chromosome. This looks to be chromosome number 3 from humans. We have all of these markers, and we know what the centimorgan linkage is between each and every one. Massive amounts of data sets went into this to generate it. So you can then calculate out what it is. And if I'm going to put this on the exam, which I typically do, I have to be very, very careful about defining the markers, showing you the centimorgan distance between them, and then giving you an example and saying this is how many this is the linkage that it goes with each and every one. So it's a big, long, complicated question to get you to understand this basic concept. So I usually try to dummy it down pretty well. Other concerns?